Okay, so we're going to go over a binomial probability problem involving basketball. March Madness is on, the NCAA tournament. So let's do something a little bit relevant to what's going on. So here's the situation. We have a player, his free throw percentage. I don't have a stylus, so excuse me. I'm doing this by my fingers. His I'll do probability of made free throw. Yeah, this is pretty sloppy. He's shooting 70% from the free throw line, okay? And he's going to shoot zero point 0.7 or 70%, and he's going to shoot 8 free throws, okay? So the thing we're interested in is determining the odds that this player makes 6 out of 8 free throws. Or we'll say, yeah, 6 out of 8 free throws. So that's a little bit higher than his average. So let's see the probability that he shoots exactly 6 out of 8 free throws. So we're going to, excuse me. So probability of random variable will be x. We'll call x the number of free throws made. So the probability x equals 6. Okay, so to do this, we're going to use, this is again a binomial problem. So we're going to have to explore a few things first. So there's two possibilities. The player either makes the free throw or he misses the free throw. Okay? So it's been given that the probability that he makes it is zero point 0.7, which means the probability that he does not make it or he misses it would be 1 minus zero point 0.7 or 0.3. Okay? So in order to do this, it might help to just write it out. Just sketch out, let's see, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so he could either, I'm going to put M for made, X for miss. Okay, so if he hits 6 out of 8, one possibility is he hits the first 6 and then misses the last 2. Another possibility, oops, excuse me, is that he misses the first one, makes the second one, the third one, misses the fourth one, and makes the last 4. Wait, 1, 2, 3, yeah. Okay, and then there's a number of ways to arrange this, right? So let's just focus on the first scenario in which he makes the first 6. Okay, so I'm gonna go to a new page now. Okay, so the probability that he makes the first one is he's shooting 70% from the free throw line, so it's zero point 0.7. And then the second one, again, in this case, we're going to assume that each free throw is independent of each other. So we're not going to assume that, well, so in the real world, it might be different. So let's say if he misses a free throw, he might be a little bit nervous, his confidence might be shaken, so the odds of him hitting the second one might be a little bit lower. Or if he makes, a certain number in a row, his confidence will be up, so the odds of him making will be a little higher. So it's important that we establish as an assumption that each free throw is an independent event. or something that's not affected by the other his other free throw attempts. So anyway, going back, it's it's a 70% chance he hits each of them. Okay. So then the other two. So again, if there's 70% chance, it's binary, as is he either makes it or he misses it. So the next two, the probability he misses it, are 30% or zero point 0.3 and zero point 0.3. Okay? So if we add all these up for this particular scenario, so if we multiply these, I'm going to go to the calculator and do point, let's see, point 0.7 to the third, to the sixth times zero point 0.3 squared. So that's going to be 0.01. It's going to be 1.06%. So you might be thinking, wait a minute. He's shooting for this particular scenario. So you might be thinking to yourself, wait a minute. He's shooting 70% from the line, and the odds of him hitting 6 of 8 are that's 75% around that. So how is there only 1% chance that he's going to hit 6 out of 8? Well, the answer is there's not a 1% chance. There are other scenarios that we have to take into account that isn't present here. As we saw in the last one, he could miss the first two and make the next 6. That's another scenario in which he hits 6 of 8. Or you could miss the first, make the second, miss the third, and then make the next 5. That's another example of him hitting 6 of 8. So these binomial problems, there is a way to calculate a formula for calculating the number of permutations or arrangements. In a way, you're taking these scenarios, make or miss, and just counting the number of ways they can be arranged. Again, called a permutation. So there's a formula for that in a way. So it's going to call, it's called 826, okay? So one way of writing this is like this. So it's 826. 826. Another way that you might see it is like this. And the formula for this is it's going to be 8 factorial over 6 factorial times 8 minus 6 factorial. Okay? And what this means is that the 8 factorial is just 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then 6 factorial, the number of makes in this case. So that would just be, I'll put it here so it's a little bit easier, 6 times 5 times 4 times 3 times 2 times 1. And then 8 minus 6 factorial, or 2 factorial, is just 2 times 1. So we can see that this part cross cancels out. And then we're left with 8 times 7, or 56, over 2 times 1. So that's just 28. So that's 28. So there are 28 different ways in which we can arrange um, the number of made and missed free throws, or um, 826. Okay? So at first you're saying 1.06. Wait, that seems extreme. He's so in this particular game, 6 out of 8, that's 75% from the line. He's shooting 70%. Normally, there's got to be greater than a 1.06% chance. So in this case, we're gonna take 28 and multiply that by 1.06 to see the real probability that he hits 6 of 8 free throws. Okay, so we're going to go back to get a more precise answer to this calculator. So we get this around 1.06%, and then we multiply that by 28, and then we get 0.29647. So we'll call it 30%. So that seems a lot better, a lot closer to what we would expect. But you also might be at this point saying, the difference between, again, he's shooting 70% from the line normally, and in this particular game, 6 of 8 free throws, that's 75%. So you're saying those numbers are so close. How is it still only 30% chance that he'll hit 6 of 8 free throws? Well, if we take into the scenarios, so that's only 6 of 8. There are 9 different scenarios. So he hits 0 free throws, he hits 1 free throw, he hits 2 free throws, and so on. So let's say the probability that he hits at least 6 of 8 free throws. So now we have to calculate the probability he hits 7 free throws and the probability he hits 8 free throws. And let's see if that is closer to 70% or what he normally shoots. Okay? So now we're going to use the same method to calculate the probability. I'm going to go to a new sheet that hits 7 free throws. In this case, the random variable is the number of free throws hit. So again, we use the formula we were given. Well, I'll write this out. Just this one might do different. I don't know why. There. 3, 4. Okay. So now we do 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.3. Okay. So again, he could, in this case, he made the first 7 and missed the last one. He could make the second free throw. He could miss the second free throw and hit the other 7. So to determine, again, the number of arrangements or permutations in which the player hits 7 out of 8 free throws, we use the equation. So basically there are 8 free throws and you choose 7 of them. So one way to express this formally is 8 choose 7, or 8, or express it like this. And again, another way of doing that is 8 factorial over 7 factorial times 8 minus 7 factorial, which is just 1. Okay, and we wrote it out in the previous problem. So for this one, we're going to make life a little bit more simple, and then another way of expressing this is 8 times 7 factorial over 1 factorial times 7 factorial. The 7 factorials cancel out, so you're left with 8. Okay, so there are 8 scenarios in which the player hits 7 out of 8 free throws. All right, so now let's go back to the calculator. So let's clear this. Okay, so now we have 0.7, seventh power, so we get 7 out of 8 times 0.3 just to the first power, or just 0.3. And then we get 2.5%. Okay, and again, that does not seem, 2.5% seems a little bit low. That's because there are 8 different scenarios in which this player hits 7 7 out of 8 free throws, 8 different permutations. So when we take that into account, we get about 20% chance. So that seems a little bit more closer to what we would expect. So I'm going to go to lecture notes if this allows me. Sorry, it's freezing up. Okay. So anyway, we'll write down probability x equals 7. We're going to get 20%. Okay? So now, let's see the probability he hits 8. He makes all his free throws, or 8 out of 8. So we're going to go over here, and to avoid redundancy, you guys should get the point. So for one more, 0.8, 0.8. Oh, shoot. So 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7, 0.7. So in this case, there's only one way to arrange it. You have to choose all 8. If you choose a number of free throws out of 8, you have to choose all 8, and there's only one way to choose all 8, one permutation. So that's 8 choose 8, and that equals 1. So for this case, the probability that x equals 8 is just 0.7 to the 8th. And calculating that, so that's 6%. So adding all these up, we get 30% plus 20%. These are approximations. Plus 6%. We get that to be 56%. So he's shooting 70% normally in this game. The odds of him shooting 75% are a little bit over his average. The odds of that happening is there's a 56% chance. So that seemed to be a little bit more reasonable. So it's a little bit above what he normally shoots. So there's a little over half percent chance. So the likelihood of that happening is a little over 50%. So that's reasonable. That seems like a reasonable answer, and it's actually the correct answer. So to summarize what we've been doing, we use the equation that I'll call, let's see, so again, it's the number of successes over the total. So in this case, there are 8 total. Here is going to be the number of makes, is the probability for a particular percent. Okay, so just to clarify, 56% is the chance he makes at least 6 free throws. So you have to add up probability makes 6 free throw, probability he makes 7, the probability he makes 8. So so this is for a particular number of free throws. So we'll say probability here. It's pretty sloppy. Okay. So see the probability x equals n. N being the number of free throws made out of 8. Okay, so to summarize the results, you give me any number out of 8, 3, 4, whatever, and then this equation will give you the percent chance that he hits that number of free throws. So it would be this percentage he normally makes, 0.7. Again, we listed that out before in terms of drawing it out, the lines, putting 0.7 for the number of them, n times he either makes it or misses. So if he misses, it's going to be 8 minus n, and then the number of arrangements, or 8, choose n. So the way you can think about it is he's choosing, out of all the free throws, think of the number of ways he can choose how many he makes. So in the first scenario, there's 8 free throws total. Let's choose the number of ways that we can pick 6 of those as made. So another way to write this out is 8 choose n. So this equation, to summarize the results, will give you the probability that he makes a certain number out of 8 free throws. And then this is a similar equation that we can use to approach any problem involving a binomial that's oriented in terms of successes with binary scenarios. Either he does it or he doesn't. So this is used for the binomial distribution. Okay, thank you.